Well, hello, hello, hello. Good morning, good afternoon. I'd like to welcome you to another episode of the NetOps Expert. And today we are joined with my partner in crime, Alec Pinkham. Alec, say hi to everyone.
Hello, everyone. Thanks for having me again.
All right. It's always great to have Alec back. And a good friend of mine's joining us today. We've been through a lot of NetOps together over the years. His name is Jason Normandin. You may know that name. Him and I do a lot of things around webinars and small bites and presentations in Vegas, you name it. Him and I have definitely done a lot of talking to our customers around this solution. So I'm very proud and happy to have on my friend and another NetOps expert, Jason Normandin. Jason, say hi to everyone.
Hello, everybody. Thanks for having me.
Jason is a product manager with the NetOps solution. He has been for at least 10 years. Jace, how long has it been?
24.
With the NetOps solution?
Years. Well, starting with the predecessor to the NetOps solution, yeah.
Oh, wow. That's amazing. Well, my apologies for making that number extraordinarily small. But that's right, because you were doing a lot of stuff before CA2. And we'll get into that because we'd love to hear what the evolution of networking looks like to you, especially over the last 24 years. But today, we are talking about AI's impact on network operations, the good and the bad. There are a lot of use cases. There's a lot of fluff out there. There's a lot of noise, and we're going to try to get through it all and maybe come up with some answers or recommendations or just some advice. So, Jason, real quick, can you tell our audience a little bit about your career, where you came from, what you're doing now with Broadcom?
Yeah, absolutely. So I started this journey back in 2000, right after Y2K. Wanted to let that kind of settle before I jumped into the technology arena. And I started in support, in technical support, answering phones and talking to network engineers, network operations people, and just, trying to solve their mission critical problems that arise. I then kind of continued in that vein for a bit and then moved over and led a sustaining engineering organization for a while. That was in the CA days. And then that transitioned into product management. So I've kind of been around the block a little bit. I haven't poked my head into the sales arena too much outside of my product management role, but I like to think I have a pretty good technical foundation.
Yeah, you talk to a lot of customers too, a lot of our customers and other customers, especially when you and I are doing shows. So you have a very unique opportunity to understand not only their technology, their challenges, but also help architect our solution to overcome those challenges. So real quick, Jason, because we want to get into AI, but I'd love to hear the evolution of networking and what you've seen change over the years, or not change, or come and go. What's the last 24 years in the networking space look like as a product manager for the solution?
A lot less ATM and a lot more software-defined network. It's, the role of networks hasn't changed, right? It's connectivity. That's always been what networks are about, connecting people and systems together. So the goal hasn't changed. The role of network operations within that hasn't really changed too much. It's always been a kind of problem comes up, respond, resolve, move on to the next challenge. What we've seen, though, and where things have really differentiated themselves is as the networking technologies have changed. Certainly the ability for operations engineers to maintain expertise is a challenge. Based off of things like software-defined technologies, moving workload into cloud, have all been really big shifts that we've seen for network operations, and they've struggled with those changes. We all know in network operations, turnover happens, right? Especially in the level 1, level 0, depending on the organization. People come and go real quick, and to train people and build them up as experts across a multitude of technologies is really not practical. So what we're seeing is the tools essentially have to do more, right? They have to provide and help plug in that gap where network operation may not be familiar with, well, how does my SD-WAN environment work, for example, but they still are responsible for identifying and solving those problems. So I would say their job has become more difficult. I think it's just based off of the diversity of tools, I've also seen quite a bit of walled gardens being created, right? So vendors having their own platform to do their own system administration and operation. And that's another huge challenge that, as you know, Jeremy and Alec, we really try to help by bridging that gap and bringing all those solutions into a single tool, right? So I can get that end-to-end context-aware understanding of a problem and not have to jump out of one tool into another tool into another tool. We know that really is where efficiency, it goes to die, and it ends up causing a lot more churn, and it just becomes very expensive to solve problems.
I think the other thing there is that you mentioned that the solutions have to get a lot stronger. It's also just a lot of contextualization, because we see this in the kind of convergence of network and security operations where, all of a sudden a small network blip actually is a security input. Which tool is picking that up? Which tool is flagging that? And who's actually getting alerted? Because we see that a fair amount in just requests of, hey, can we import our data into another system for contextualization? Or can we import your data into your solution for contextualization? Because it's starting to get a little bit more complex, as you mentioned, the cloud migration, the movement of workloads, and just the movement of people. Now we have to worry about a lot more data and a lot more kind of contextualization of where that data is coming from and what's it actually telling us.
Yeah, we've seen that with the big data phase, and I don't want to say the big data phase came and went. I think it's still here to some extent, but the big problem that folks dealt with was, I just have all this information. I don't know how it's related in any way, shape, or form, right? So getting the data out of a system and into another system doesn't necessarily solve any challenges, and in some instances creates new challenges, as that data just now is, well, what is this? How does this relate to service Y? Or how is this having financial impact? And it becomes extraordinarily difficult once you do that. Segue into kind of, the AI bit, because I think the AI revolution can certainly help in that regard.
Yeah, I know that's what a lot of people are asking for, right? Is for AI to help solve those problems, to help, show me what's actually important and just get rid of all the fluff or all the, we talk about it with, root cause isolation and alarm noise reduction, right? Get rid of all the ones that are, downstream or upstream from the actual problem and tell me where that one is.
Yeah, great segue. And I think we all would agree network operations and networks in general have been turned on their head, from software defined, promising the world, and hybrid work, moving users out of the corporate office to cloud, and more use of SaaS and ISP, moving workloads out of the data center. Now we're going to throw AI in there and promise the world. So, Jason, what do you think, from a high level, AI's impact will be on network operations? And that's with stating, hitting some of that low-hanging fruit that Alec was just talking about, and then maybe even some more impressive use cases.
It's at the end of the day, in operations, it boils down to cost reduction, right? Cost reduction of the people and processes and tools that are required to solve a problem, and decreasing the financial impact of problems when they occur, right? An application is down, there's some sort of service outage. Those are all very costly. So the goal of AI in all of this is to solve more problems more quickly and be able to identify when smaller issues will have a larger effect, which may not be immediately visible when a small problem arises. So I think it's an efficiency boost is really what it's about. You certainly can do a lot of things, and the AI conversation has significantly changed over the last 12 months or so, where it's become real. If we would have had this conversation 2 years ago, we would have talked about, well, AI is a buzzword. I don't think it's a buzzword anymore. It's legitimately here. I'm sure you all have used ChatGPT and whatever other clones are out there. Clone's a bad word. Whatever other competitors are out there. And you can really see how it actually is a valuable tool. It's no longer a curiosity. It's becoming a critical component of enterprises and how they are going to advance, over the next year, 5 years, 10 years.
Yeah, I think AI, I would disagree only in the point that AI is the buzzword, because you then have to go into what is it actually doing for you, because now there's so many different applications of it, right? Because I think early AI was pattern recognition, pattern matching, things like that, right? And now we're getting into AI. They, a lot of the analysts will say AI ML together, right? Machine learning is, one application of this that then bolsters an AI to give you better data, better information. There's natural language processing, ChatGPT comes into that, right? Gemini, all those. But I think the interesting part is, where do those actually help network operations? Right, we've heard about it in a couple different places. I know one of the ones, Jason, we talked about was the idea that there's maybe something we can do with getting network engineers up to speed faster, right? By giving them some of these tools to help them get rid of the noise in the system. But I wonder what you think about, what is the application that you're thinking of when you think about L1 network engineers?
Where AI currently sits today, and I'm going to talk about the large language model, because that's really, I think, the most interesting at this point. Is it, and this is a key aspect of that technology, is it's an assistant, right? It's not a fully autonomous mechanism that can go off and do everything on its own and there, take the people out of the loop. It's really augmenting of the human intelligence and knowledge that's already there with whatever data that particular model might be focused on. In many instances, it's the internet, but there are also instances where training that on more specific subsets of information, and certain enterprises taking advantage of feeding it in their documentation and knowledge base, things like that, where now it becomes a mechanism that I think the vast majority of people are familiar with, asking a question, right? Like Google, like, what's going on here? What does this problem mean? How do I solve this particular issue? All of those things now become an interactive mechanism in which the operations engineer can consult with the AI. It's important to note that that AIs can still fabricate information, right? It is a large language model, so that's its primary focus. So having AI unchecked and having the leash cut off is not anything anyone is ready to do. It's more, let's supplement what we already have. Let's provide a means for our teams to take advantage of tribal knowledge by bringing all that data in, asking questions, and getting real results about how I can go about solving the problem. If I'm having application latency issues to my application in my Azure cloud, what kind of things should I look at? And those are things that AI, I think, is really primed and can solve today, through that kind of interactive question and answer approach. The one thing that I think is important to note is that automation is such a hot topic. The customers I speak to, they're not ready to turn over the keys for changing of networks to AI or ML, or even their own engineers in many instances, right? There's still a significant amount of paranoia about, well, we're going to make sure every change that goes in, there's somebody that understands why that change is being implemented and what the potential ramifications are. Eventually, when Skynet comes online, it will probably take over all of that automation. But for now, it's still very much interesting, but I don't want to, bet my income on it by wiring it all together to solve problems automatically without any people.
So you're asking for Clippy for networks, not Skynet for networks.
Yeah, I'm a fan
somewhere
of
between, maybe.
It's that human approach, right? Where it's easy to understand what is being suggested or asked, because it's communicating like we would be communicating, right? It's not just throwing data, it's not just making decisions, but it's providing input and value as the questions are asked.
Jason, Alec just fed me a data point from our good friend Seamus at EMA in his recent Megatrends report. And correct me, I don't have it in front of me, Alec, if I'm wrong. But one customer said AI is their hope for event and noise reduction. They can get to 90% noise reduction by hand with some hand-built tools, but seeing 95 or 99, they just don't know how to get there without AI. Can you tell us what that customer is talking about? Is it possible? What's the functionality and capabilities involved to getting possibly to that 95, 99%?
Noise reduction is certainly a interesting topic and is always on the forefront of our customers' minds, right? Because there's a lot of savings to be realized by less churn, and I think where that's going to come into play the most is around the aspect of understanding relationships between items, right? Understanding a topology. How are things connected? How are things communicating? So that when an upstream event happens and then that ripples its way downstream, these things now can be understood as part of a delivery chain for a particular application or service. Whereas before, the noise reduction would be pretty minimalistic as far as the technologies used to determine if something is noise. Is it a recurring alarm? Is it something related to a root cause? That's a whole other conversation, the root cause bit. But is it something that is related to the same device or in the same subnet? There are different ways that that type of noise reduction can be done. And you'll get a good amount, right? That's the 60, 70, maybe even 80% noise reduction through those methodologies. But you're still left with quite a few problems, right? Quite a few issues. In some instances, they are going to be isolated issues. And where I think AI can help there is it can identify what a potential risk is for that particular problem, right? If I'm getting a critical issue, that doesn't necessarily mean it's a critical issue impacting service delivery. But in the context of the larger understanding of the network, as well as historical issues that have occurred, it can kind of start to identify, hey, this is an issue that has happened before. It's related in this way because of the topological connectivity of this. And we have seen this then transcend into downstream issues and eventual outage, for example, right? So it can take that single isolated issue that occurs at time +1, it can tell you, hey, in time +10, you're potentially looking at a service outage based off of what we've seen in the past. So it's a very different way of noise reduction. It's almost a bit of a predictive where it can then understand, hey, we've seen this. Now we expect to see, ABC following, and it can bring those together for the operations team so they can understand how a problem is unfolding within their network, right? Rather than it just doesn't always just simply present itself in one foul swoop, right? There's usually a trickle-down effect that happens as a circuit goes down, that traffic is moved to another circuit, that circuit begins to experience, overloaded capacity. It then leverages additional circuitry for additional capacity, but that added 10 more hops to my route, and all of a sudden my latency has, tripled. So they're really, networks are very resilient, and they're going to move traffic around however it needs to get around an outage. But understanding the implications of what happens when that traffic is moved, I think is a huge area where AI will eventually start to provide that, hey, don't do this because it's going to result in, a bigger problem down.
Yeah, and I think that goes back to something we talk about a lot is getting towards a proactive stance on these issues. And I think understanding that chain of events is something that has been very difficult up until now, because you're getting an alarm for one thing, an alarm for another, right? You get an alarm for a switch, you get an alarm for that circuit, right? If you're not contextualizing, if you're not putting that together and then stitching them and saying, hey, this happened, a minute before, this happened 5 minutes after, right? It's much more interesting to see that whole chain of events now where we can look at it and say, oh, when we see this in the next time it pops up, because this is all cyclical, right? We see these kind of periodic issues all the time that show up every once in a while, and we don't solve them, or they go away and we're like, well, I guess it's fixed. Hope it's not coming back, right? I think that's the cyclical nature that we can get into and get proactive on it. But it does require a lot of data, right? We kind of go back to that story is you do have to have inputs from every part of the delivery path in order to understand, where's that impact. We talk about this a lot when we talk about internet outages. Is if the internet's down, that's fine. Is it actually impacting me? Is it impacting my apps, my users, right? That becomes a slightly different discussion. And I think that's where we get back to that kind of proactive language, which I like.
Absolutely. And that's a big reason why a lot of the data lakes, quote unquote, didn't quite pan out, right? Because the amount of information needed, as you mentioned, Alex, to contextualize that, to say, oh, these things are interrelated in some way, shape, or form, would require either a massive amount of curating of that data, right? Adding additional metadata that's being sent upstream so that correlation can be done. And that correlation would always have to, in many instances, machine learning, there's a lot of training that has to go on with machine learning, right? It's not a generic model by any stretch of the imagination. It needs to be spoon-fed very specific types of data to understand what that outcome is going to be. Where I think the large language models kind of work in a more autonomous way, where those hints and those cues, they don't need to be as readily apparent because the interrelationship of that information can be discerned, right, more naturally through those large language models, and you don't have to do nearly as much. You probably heard it called decorating of the data, or just augmenting the metadata to get more of that understanding. So it's going to be a really big change once this becomes more standardized and mainstream. And in enterprise software, we know it's usually a couple years behind consumer-based technology. So by the time we get AI into the enterprise tools fully integrated, all of the licensing and data privacy concerns sorted out, be a little bit of time. And during that time, the sophistication and the maturity of these models is just increasing. I don't want to say exponentially, but significantly. So, I think the future is very bright in these instances. And I think what we're going to be able to do is going to be surprising without requiring nearly as much R&D effort as would be required, a year ago.
Jason, you mentioned some good use cases around noise reduction, event correlation, even capacity or predictive type use cases down the road. What's this going to look like? You and I have talked about like a knock bot, and Alec and I too. A L1 knock operator comes in, starts a shift, and maybe he says, "Hey, knock bot, where do I need to focus my attention this morning?" And if he's got the right data in the system, he's going to know that there's been maybe some utilization spikes in Seattle or Philly or, whatever is being monitored across the entire network path, instead of looking for a needle in a haystack. And you're agreeing with me, but I thought of something while you were talking, which was, what's one of the biggest issues we have outages today when it comes to humans?
Configuration.
Like misconfigurations, right? Overwriting a configuration and it pukes. Do you think we could have a configuration ready to go that we need to update? This is the updated configuration. This is the current one, and have the AI engine or robot review it, proofread it for us, and understand how the rest of the network is running and say, yay or nay, this config's going to work, or you're going to drop every device in this architecture. You think that's possible?
Absolutely. I think it's more than possible. I think it's imminent, right? It's having the ability to, and this is an area that, we have a network configuration change solution within NetOps, and we know this is a very valuable area, right? Because as you mentioned, the cause of most outages are human-related, configuration change-related. So, one of the things I think we're going to see become the norm is the ability to model what changes are going to be. I have this configuration change I want to push up to solve a problem. What is the ramifications of that change? And right now it's I'll cross my fingers and hope it's good. Mm-hmm. Whereas, having an AI review those changes in the context of how your network is running and operating today will be very, very valuable, right? If I want to change a particular, how a particular route is being determined, I can understand if that's going to potentially impact a different application that's being delivered, right? Because again, moving capacity from one link to another link potentially impacts something else, right? So then you're going to be dealing with performance issues somewhere else that you didn't expect, and what's going to happen there is a new issue is going to be opened up, and tracing it back to that configuration is extraordinarily hard. So I think that aspect of, hey, what if I make this change? What happens to my network? And here's here's how my topology changes, or here's how, the flow of data is going to change, or here's how a prediction of what that performance is going to look like based off of, baselining I've done in the past, things like that.
Yeah, I think that last part's super important, because the traditional way of thinking about, modeling a configuration change is based off knowing exactly what infrastructure you have in place and where that traffic is going primarily. But as soon as you include cloud and ISPs in that discussion, then you sort of lose that, right? You add SD-WAN into the mix or any overlay type technology, you've got an even harder problem to solve. So I think using those baselines and understanding, okay, I can predict with a lot of certainty what's going to happen in your network, and with a fair amount of certainty what's going to happen in the dynamic side of the network that's outside of your control. Because I feel like that's the visibility side of it that, we've talked about it with data, but now you start talking about modeling it. Like, you have to have baselines of what that performance looks like. And with dynamic networks, it may take a little while to build those baselines, but not, exorbitantly long time. It's just going to take a little bit of time to make sure you understand, what happens on a normal weekly or monthly cycle, right? When you overload those links, are they going to throttle you, or are they going to switch you to a different, you've got a bunch of different ways to kind of look at that over time.
Absolutely. And being able to even understand, the underlay components associated with an overlay, that's hard enough as it is already, right? There's only a couple tools in the market that can do that for you, right? And that becomes, if we're going to talk about this modeling of how things impact downstream, that becomes, mandatory. There's no longer, well, it leaves my building and then I don't care what happens anymore. That's really, no longer satisfactory. Now I need to understand the end-to-end delivery chain of applications and services, regardless of where they go, right? So that if I do make a change, I can predict, hey, this is going to cause, if I make a SD-WAN change, I want to know, hey, this is going to end up moving 20% of your traffic over to your MPLS connection. Is that really what you want to do? And in many instances, the answer will be no, and they'll be grateful for AI. But again, it's not meant to supersede, the human influence at this point. It's a way to check. It's a way to validate. So again, it's more an enhancement of what we can do today rather than a replacement.
Yeah, Jace, you and I know, and Alec too, we talk about, and it's been our story for a bit now, trust but validate, right? Especially in the SD-WAN space and controllers and automated routing. I was recently talking to Chris Grunderman. He is heavy in network automation space, recently launched the AutoCon conference, started the Network Automation Forum. And a lot of things around what he's doing, the main question comes up, which is, how come network automation hasn't caught on? So as we move to this last topic of AI and automated triage, it sounds like you might agree, but please go into it more. We're still validating, we're trusting but validating. What are we doing? Is there really automated triage in AI that we're going to look forward to soon?
So automated triage, I think, absolutely. And automated triage is really about getting the right information to solve a particular type of problem, right? If I'm seeing this, well, I need to get these 4 things on the list to kind of understand what's happening more. And the AIs will do a good job of not only incorporating, things like run books, but coming up with potential novel things as well. And then learning, obviously, as that those conversations continue. But I think as far as making changes, I really think for a while it's going to be on training wheels. I could see it proposing, hey, you have this type of problem. This is what I would suggest to do to solve the problem. And this is what we expect the ramifications of that change to be. Do you want to make the change? Right? I think that's probably the next step that we'll see. Right? And I'm sure that exists in some way, shape, or form in some tools in the market today. But in my experience, it's usually not very accurate, especially in the network world where there's so many different technologies, so many different vendors out there. It's really hard to have this, one size fits all. But being able to model and understand, as we talked about, how a change is going to impact, will start to give more trust from those teams to say, hey, 99 out of 100 times what it's recommending is correct and has solved the problem. And then eventually that percentage will become acceptable, and folks will be like, all right, well, let's flip the switch. And then, at that point, we're going to see, I think, a change in what the investment in people is bringing to the company. Rather than spending all this money on people to press buttons, they're going to tap more into their intelligence, their innovation side of things, right? To not just solve problems, but to figure out how to keep those problems from coming back in the future, right? So I think the resiliency of networks is going to improve for sure, especially as more of our investment in network engineering and network operations can be used more on the proactive side of the house, more on the avoid this problem in the future, or, hey, now that we know what this problem is, let's understand it so that if it comes up again, we can solve it quickly, or we can predict when it begins to unfold and be able to solve it, before it even impacts the organization, which is the dream, right? If a problem comes up, solve it before anybody notices there's a problem.
Yeah, I was going to say, I have two things to follow up on that, and I think they kind of dovetail together. The first one I'm thinking of is that just like AI prompt writing is super popular right now, as far as, who can write the best prompts to get the best out of AI, I think with network operations, it's going to be AI constraints, right? It's how can I put constraints on what actions the AI can do such that it can't blow up the entire connectivity. Right. Because I think the constraint side of it, and it's given me flashbacks to engineering and degrees of freedom. Right. It's like how many people spent time in Excel using Solver doing this, like making sure that it could only, move numbers in one direction and not the other. Right. Making sure you can increase capacity, but you can't clamp it down or shut it off entirely. Right. Little things like that, I think, are going to be really important when we're talking about the automated remediation thing. And that brings me to the second point, which is it goes back to the skills gap. Right? There's a lot of things that you were just saying that AI can really help build the efficiency of our higher level network engineers and start expanding the role of our L1s, right? Of giving them a little bit more ability because it's going to teach them, right, along the way of, even if it's not making the change, it's saying, hey, this is what I've seen. This is what we've seen in the past, right? Bring in the knowledge from, older generations. That was the whole, a couple of years ago, everyone was talking about institutional knowledge, store it in the database, right? That's what we can use to teach these systems, right? It's got to be finagled and pushed into the right formats. But I think that's the part that we want to look at with the skills gap is if you have a tougher time teaching new engineers all of these basic things about networks, right? Maybe they come in from the cloud side and they know really nothing about how to build a topology internally to understand exactly where data is flowing, right? We can build that for them, and then we can show them, hey, when this breaks down, right? And start making those connections for them, right? It's a longer road, but I think that's the thing that gets me is, we need to get to the point where and this is still sort of an if automated remediation is that panacea, is that pinnacle of the pyramid, then what do we need in these models in order to get people to then write the right constraints to be able to solve that? So, I agree. It's still a little ways out.
Yeah, absolutely. It's going to be time on task, right? And it's going to be slowly building up. It's the trust factor. It's, how accurate and reliable. And the only way that that's going to be proven out is over time and through kind of the assisted mechanism, right, where it's an interactive. Here's what I would suggest, like I mentioned, versus just putting a change in and, let's see what happens. So, yeah, again, I go back to the point of where AI is and focusing on the large language model. Again, they are meant to assist human beings at this point, right? They require a good prompt, as you mentioned, right? A good understanding of how the problem is being framed. How should I give you this information? And then what constraints should I apply to whatever that output is? It's really going to mature. And this is where organizations are going to be able to feed in that institutional knowledge as well. So it'll happen. Absolutely. I just think it'll be a slow curve. And that trust factor will get built up over time.
Well, training wheels sound good. I recently asked an AI image creator, to create two guys sitting on a sofa with hoodies and sunglasses. And it did that, but one of the guys had like 7 fingers on one hand. And his face looked like he went through like a car accident or something. So training wheels sound good, but the possibilities sound amazing. I can't even imagine the possibilities in every sector, from healthcare and getting resilient access to real-time patient data, even with a wearable, right? Or manufacturing and getting goods out faster, to financial and making, amazing investment decisions for your customers and clients. I'm sure the use cases are endless at this point. Jason, as always, you're a good friend of mine. I miss you, buddy. I'm so happy that you are here talking to us about these topics. I'm sure we'll have you back on for some more. And Alec, as always, it's great having you as my partner in crime. Jason, any last words on the AI topic in network operations before we sign off?
I would just say it's coming, right? I think my advice, if you're in an enterprise listening to this, is be patient. Right, rolling out ChatGPT is very different than rolling out embedded AI in an enterprise class software. So have some patience. But at the same time, I think the end result is going to be a significant change, one of the largest we've seen in this industry in a very long time. And I think it's going to change the landscape and potentially have significant impacts on resiliency of networks, right? Less outages, less application issues, because there is more intelligence built into understanding how these things interoperate.
Excellent way to round out this podcast. Jason, again, thank you so much for your expertise and your collaboration within our solution that we so dearly love here, the Network Observability Solution at Broadcom. That's it for us, guys. I want to wish everyone a wonderful rest of your week, and we are signing off here at the NetOps Expert.